So today's goal, good morning everyone. Today's goal is to basically get started with group functions and subqueries, generally speaking. My first thing I want to do is review the functions we had talked about last time. Then talk about lab 4, which is up and coming. And after reviewing group functions and subqueries, we'll talk about how lab 5 can be attempted, because I think you guys will be starting that. You'll be starting that next. So, in reviewing your assignment 4 is due on February 10th, and 5 is due on February 17th. So whatever we would be done with today will be on the midterm. Whatever we cover next Tuesday, the 14th, will not be. They'll basically get on the final. So first 5 assignments, if you do fairly well in, I think you should be in good shape for the midterm. Moving forward, the first thing I want to briefly look at is all the functions we had talked about. So functions are basically single or multiple row. We haven't paid much attention to group functions yet. We're going to be spending time on that today. But a function, generally speaking, is a construct that allows you to compute some functionality and return one value. Something like that. It will compute something and return one value. So you can get functions to either work on a single row, or you can get these to work on multiple rows. And the idea is that there are different types of these functions that work on different data types and also enable data conversion. Specifically, when we are dealing with data conversion, we are talking about 2 char, 2 date, and 2 number functions. These are character functions, and I would recommend trying each one of them. We also have number functions, round, truncate, and mod. And these produce different results depending on the usage. And then we have how dates are interpreted in Oracle. You've got all these properties all the way from century to seconds that are tracked. So, and there is also a format in which date is represented. So, using that format with 4-digit year is the safest bet in all cases. Arithmetics on date is possible with adding days and hours. So something like that, where this is subtracting days using a minus operator. And then you have all these functions available. I just wanted to double check if you all are getting good audio quality. Just let me know if you see any degradation in audio quality at all, everyone. So we have different types of date functions that are applied, and then of course the data type conversion, implicit and explicit both. Implicit conversion means what Oracle handles automatically when value assignment works. So for example, when we go from varchar to or char, that can, if assigned to a number, is converted automatically. And same to the date data type. And similarly, if we look at number and date, that changes to varchar 2 automatically as well. So these are for assignments. This is for expression evaluation. So if you have to change the values explicitly, then you call one of these functions, toNumber, toDate, or toChar. And there's a format model that's used both with date and number type, and you make sure that you know the parts. There's a lot of features available here, like if I wanted to spell out the day, state of 4-digit year, and so on. So, can everyone hear me okay? Okay. So we have toChar, toNumber, and these functions. We also talked about the RR and the YY format. So make sure you know this fairly well. And then the usage of the NVL function with date data type. If we are trying to write an if-else statement, we can use the decode function. This is one of the general functions available to create if statement like approach. So I think we talked till about this slide on nesting functions, and today we are going to pick up on group functions. What I want to do next is, you've probably had a chance to attempt lab 4. So I want to spend a few minutes on this to provide any assistance on the approach for each part, which I think some of you have asked for actually. So we'll do that. So on the first question, it says display the manager number, which is so manager number is the MGR column in employee table. So display MGR column and salary of the lowest paid employee for that manager. So we have to display salary, and we have to use min function. So this will come together when we cover group functions, which I guess we should do. And then it says exclude anyone whose manager is not known. So let me come back to lab 4 review after the group functions are done, because we are talking in the next question about average salaries, minimum salary, and so on. So I think we ought to go through group functions to attempt lab 4 successfully. So group functions are a set of functions made available to us so we can work on group of data or set of rows together to get one result. So in this case, if I'm looking at salary column with department number, I can say for the highlighted data, which is off by 1, what's the maximum salary? So maximum salary from this set of 14 is $5,000. Similarly, I can look at data set. I can look at groups of data, not just one group, but in fact multiple groups. So in this case, I'm saying let's look at department 10, 20, and 30 and find the average salary by department number. So we're not just looking at data for we're not just analyzing one entire data set to compute final value. We in fact are looking at we're taking the data set and grouping it by department number to get the final value. So when we do a group by department number in this case, we can see average salaries for each of the departments. So there's not only the capability of grouping but you can also do a lot of subgrouping, if you will. So we have a ton of functions, 7 of these that we can use for grouping data: average, count, max, min, standard deviation, sum, and variance. So using group functions in select statement requires that you put the group function in the select statement. So that's the first order of business. So saying something like this. So like give me average, max, min, and sum. That's the application of a group function. Give me average, max, min, and sum of the salaries. You can also use a star next to, instead of the specific column name, in which case it basically star there acts like a wildcard and it will use all the rows. Then we have this group by clause that we are introducing in this section. This is the part that allows me to create subgroups. So if, as you can see, group by clauses in rectangular brackets. And what that means is that it's optional. But if I add the group by clause, and I start to specify column names like department or others, then I'm creating these kinds of subgroups, if you will, that I showed earlier. So when I say group by department number, then it will take department 10 and make it a subgroup, department 20 and make it a subgroup, and so on. So let's look at each of these functions applied. So average will give me the average value of the salary. So it will take all the numbers, come up with the sum and divide it by the number of rows. Maximum and min is going to give me the maximum and minimum salary, and sum is going to give me the total salary. And these functions are going to ignore the null values. That's why we have to use the NVL function to convert any null values to a numeric value. Here is min and max with dates, which is pretty nice actually. The person that was first hired, person that was last hired. Here is the count function that returns the number of rows in a table. It returns the number of rows in a table. So as you can see, count star, right? So you have to apply this. And if I use commission, you can see it only returns 4 rows, which suggests that the group function ignores null values. So if I say average of commission, it's going to take the number of non-null values, but yet divided by the total number of actual rows, in which case, without application of the NVL function, the results might be inaccurate. So you end up doing this, and then the result is, in fact, accurate. So group by allows us to create these groups that I've spoken to before by using this group by clause. So we can create smaller groups. So whenever we say group by department number, let's say, we must select department number on the top. So what that is saying is that all columns that we put in the select list that are not in group functions must be in the group by clause. So if I end up selecting department number or others, then I must add those in the group by clause. So if I end up selecting another column like name, because I want to show the department name, then I must say group by department number, comma, department name. Those are things to watch out for. Yet the opposite is also true, that if I just wanted to print an average of all the department numbers, I don't have to select that column. So, department number is essentially removed right now, right? Department number is essentially removed right now. We can group more than one. By this picture, what can you tell? We're trying to group by department number and job. So when a query like this is written, this is what it looks like. We say group by department number, comma, job. Group by department number, comma, job. So we have several illegal queries. What's wrong here? We are using department number, but we did not say group by department number. You all see that? If you don't say group by department number, that's going to provide an error like this. So we cannot use group functions with the where clause. We cannot use group functions with the where clause. Bad idea. It'll generate an error. If we need to say average salary greater than 2,000, then we must use the having clause. So if we are trying to exclude certain groups like salary greater than 2,000, then we have the having clause. Having clause with a group condition. So something like that. Max of average salary is greater than 2,900. So, or having sum of salary greater than 5,000. So having clause is an important one if a condition needs to be applied on a group function. If a condition needs to be applied on a group function, then we use the having clause. Then we have nesting group functions. What is this gonna get me? I'll first compute the average salary for each department and then bring out the maximum average salary. Right? I'll compute the average salary of all departments because I'm doing a group by on department number, and then I'll find the maximum salary, maximum average salary. So I think now it'll be more fun to work on lab 4. So display the manager number and the salary of the lowest paid employee for that manager. So this is bringing manager ID and the salary of lowest paid employee. And here we can use the min function on manager column. And what would you do a group by on, folks? What would you do a group by on?
Muted. Unmuted.
What would you write? So do a group by on MGR. Do a group by on MGR column. And what else? Then it says exclude any groups where the min salary is less than 1,000. So you'll use the having clause or the where clause. Which one would make sense? Because we want to exclude any groups where min salary is less than 1,000. So we should use the having clause here, not the where clause. Okay? And then we do an order by on the salary. So we do an order by on the min sal column. Okay? That'll get you the answer to the first question. Let's move on to the next one. Write a query to display department name, that'll be D name, location, and now we come to number of employees. Okay, so this means that we have to do a join between employee and department table. We have to do a join between employee and department table on department number column. And then we are talking about number of employees. So I would like the fact that if you did a full outer join using the new syntax. So that way you can get all employees in all departments. And then you can do a count on department number. You decide which one, whether you want to use the department number in the department table or department number in employee table. I would recommend using D dot department number, which would be using the department number in the department table. And then we do a count on the for the number of employees, and we also do an average salary. So we can do an average with D dot department number. And then we'll say group by department number. And then of course you have to provide these labels on top that will give you the outcome. That's question number 2. Write a query to display department names with salary grade, min salary and average commission. So this is also a join between department and EMP and sal grade table. This is a join between these 3 tables. So we figure out min salary. We figure out min salary using group by on department number. We use min salary with group by on department number. And then associate min salary to sal grade. So if the minimum salary is between 1 to 1000, then it will be sal grade 1. This will be using between operator. Because if you look at the sal grade table, you're going to find if you use the sal grade table, you're going to find the min and max. And we should use NVL for null commission. We should use NVL function with that for null commission. To print average commission, that is just using group by on department number. If you would rather take min salary plus average commission to compute sal grade, you can also do that. Another approach for solving this could be that you use total of min salary and average commission for each department to look up sal grade. Okay? So you can either base the sal grade on just minimum salary, or you can take a summation of min salary and average commission and compute the sal grade based on the sum of the two. Any questions from anyone? Okay. So the next one is basically saying, well, let's try this out and answer the question basically. The question is, what's the difference between all these? And this is to be answered by you guys, and you really need to focus on what? You really need to focus on actually implementing this with, I would use an MGR column, ename column to try out different varieties to come to a conclusion for an answer to this question. I wouldn't do this any other way. So, and then the last one actually is, well, it's actually a very simple one. Employee number, name, salary, and salary increase by 15% expressed as a whole number. So I guess you just need to format the salary increase and label the columns properly, and then you're done. Okay? So that's lab 4. Any questions, folks, or was this pretty clear? I know some of you have already started attempting this, so which I guess is a wonderful thing. And I am a little behind on grading, and I'm going to be caught up by end of today grading your lab 2 and lab 3. So, okay. Any questions from anyone, or is everyone doing okay? A quick response will help out from a couple of you just to make sure you can hear me. And then we'll move on to the next topic. Folks, can you hear me okay? Can we add more item in group by? Depends on the requirement. So yeah, you can always do a, I mean, if your question is, can I do a group by on more than one column? Then the answer is yes. Certainly. For instance, in question 3, yeah, you can. So I think a further question on that could be, like with a query that you may have written, email me that and I'll respond to your question. All right, let's work with subqueries. So who has more salary than Jones? So we figure out Jones' salary and plug that into the outer query. So which employee has salary greater than Jones' salary? So that's also a correlated query. You figure out the results of one and compare it with the other. So the subquery executes first. The results of that are passed into the outer query. And the results are used in the outer query to produce the final results. So we can say something like this. If I were to say salary is greater than something, then I can put a subquery there, get one result and apply. So subqueries can be used with the where clause, with from clause and having clause. They're also used in the update statements. Here are some facts about subqueries. They're usually enclosed in parentheses, exist on the right side of a comparison operator and not added in the order by operator. So we can use we must get one value from a subquery with simple comparison operators. And when we work with in, any, and all, then we can get more than one value. Multiple row operators are like in, any, and all operators. So we can use those with multiple row. So these are the different types of subqueries we just talked about. Single row subquery, where basically one value is returned by the inner query to the outer. Multiple row subquery will return more than one row, and multi-column is more than one column and of course more than one row. So we're going to deal with all three types. These are operators, relational operators that we use with single row subquery. So we can say that I want to find all employees that have the same job as employee number 7369 and salary greater than 7876. This is an example of a correlated subquery. You'll be asked this question, of what a correlated subquery is, and you can say, you can apply a correlated subquery to all these three types of subqueries: single row, multiple row, and multiple column. Single row, and multiple columns. So here is a group function applied. So we can say we want to get employee name, job, and salary for a person, for all individuals that have salary equal to the minimum salary. Or we can also say salary greater than the minimum salary. We can also use a subquery in the having clause. In this case, we are saying that we want all department numbers and minimum salary of individuals that have min salary greater than the min salary for department 20. So these are all different types of correlated queries, different types of correlated subqueries. Now, if a value from a subquery returns more than one value, so let's say, or it doesn't return anything, then that can be a problem for a single row subquery. So in this case, we are saying group by department number. So if a subquery either returns more than one row or doesn't return a value, then we'll get an error. Here, we don't get anything at all. So we say job is equal to essentially null. So we don't get an error, but it does not return any value. So it simply says no row selected. We also have three new operators, right? In, any, and all. So in is equal to any member in the list. Any is comparing to each value using an OR connotation or the significance is or, and all is with using the AND operator. So here is usage of any operator. So I want to select employee number, employee name and job from EMP where salary is less than any of the clerk's salary. Salary is less than any of the clerk salary. So we go out and select the salary of all clerks and we basically say less than any. Same thing for all. We say it's greater than all average salaries of the department. We want all employees that make more money than average salaries in all departments, which is different than saying the highest average salary of a department. Here, the effect is the same with the highest average salary, but we are comparing with each value using an AND connotation. Here, in this case, it uses the OR connotation. Then we have multiple column subqueries where the output from the subquery has more than one column. So main query can have two columns and the subquery can return more than one row, and so we end up comparing each set, like manager 10 with salesman 30. And that provides a value of its own. If I'm trying to display order ID, product ID, and quantity of items that match both product ID and quantity of order 605. Maybe I'm just trying to place an order. I'm trying to duplicate an order, like items in the order. So here is a multiple column subquery where we display order number, product number, and quantity that match both the number and quantity in item order 605. So that is where each row, product ID and quantity, is compared in the select statement. So if I have 4 or 5 or 6 values coming out of the select statement, the outer query will be compared with each row from the outer query will be compared with 6 values. So these are pairwise comparisons. And what we are also talking about is a non-pairwise comparison. When we do a non-pairwise comparison, we simply will end up with two separate parts in the where clause. So we will say where product ID is equal to, select all the product IDs from order 605 and quantities from order 605 and use an AND operator. So that's a non-pairwise comparison. And the former right here is actually a pairwise comparison where we take a row from the outer query and compare that with each row from the results of the inner query. And we get some results like that. If we have null values in a subquery, if we end up with a null value in a subquery, then the outer query does not return any results at all. So we can also use a subquery in the from clause. And in this case, we try not to use aliases and columns in the subquery. Here, the subquery acts like a table. Here, a subquery acts like a table. So what that means is that we can do a join between the two tables for a result like we would with a normal table. So if you have a odd query criteria and you need to where you need to join a couple of tables and bring in the results, then those can be put into a from clause. So I think you should be able to look at lab 5 after this. So let's talk about that. So in assignment 5, there are two questions, one with 3 parts and 2 with 2. So total of 5. So we are saying create a query that displays employee name and indicates the amount of salaries through asterisk. So each asterisk signifies $100. So if an employee has a salary of 1,000, then we will display basically 10 asterisks. You obviously will not show the 1,000 value. And you can use a function called lpad to do this. You can also use decode, but that's a longer route. I wouldn't recommend doing that. I would recommend using lpad. And you have to sort the data in descending order, which is sorting can be done with order by. Sorting is done with order by. So that's question 1. In question 2 is basically applying single row functions. So you have to hunt a little bit in the slides to figure out, well, employee name is easy. So you have to print employee name, username, hire date, salary, and salary review date. And each one of these requires, each of these 4, not ename, each of these requires applying a function. Like username is the first 2 letters of the name in lowercase. So you'll need to use a lowercase function. You will need to use the first 2 letters from the string. So you'll need to figure that out. Hire date and salary can be placed as is. Like salary should be rounded, it says, so you might use the round function and the format function. Hire date might use the format function so you can display the value in as a 2-digit year. That's the requirement. And salary review date will require adding months using like the add months function. Oops, I was not supposed to tell you that. So you figure out these functions and apply them in this query. And then in part 3, use subquery to display all employees in department Boston with a salary greater than 1,000. So the challenge here is you have to use a subquery. The next one is a simple one also. Display employee name, job, and hire date of all employees that started between those dates. So you can use the between operator with date function, or you maybe need to use some condition. And then you need to concatenate some columns using a specific formatting criteria and show the results. And the last one is, what's the difference between a correlated query and an inline view? So you should read up on that and answer that question based on what we have discussed today on correlated queries. So that's everything for today, folks. If you have any questions, let me know. We're going to start working on stuff for lab 6 on next Tuesday, and then I think that the week after we have our midterm. So everything that we have covered today, will be on the midterm. So if you want to look at some more examples on subqueries, you can look at your textbook for that, please. Book has an entire chapter on subqueries that acts as a good reference. All right. Have a great rest of the day, everyone. I'll be around in case you guys have more questions to help you address right now. Otherwise, I'll see you all next week. Same time, same place. Bye, everyone.